All right, so we're going to finish up the notes from yesterday. You might want your calculator at one point just so I can prove some things to you, but we're really not going to use our calculator today. So we went through lots of ways to find real zeros. We have factored, we have graphed, we have factored with long division, we have factored with synthetic division. Well, all this is well and good, but all of those we knew at least one factor. You were given one of the factors, right? What if you don't know any of the factors at all, and it's not a quadratic? You got to have a way to figure out what the factors are. So today we're going to spend some time with the rational zero test. Key word in here is rational. Are all zeros rational? Well, let me put it this way. We can have an irrational zero that's still real, can't we? Think of the quadratic formula. What kind of answers would be irrational with a quadratic formula? A negative underneath the radical would mean that it's not real, it would be imaginary. So it's not even irrational. If you don't have a perfect square underneath the radical, won't it turn out to be a decimal that doesn't end or doesn't repeat? Wouldn't it look like pi over there? Didn't we have some zeros when we graphed that were like 1.5324, there was no repeat pattern, but you knew that it was a decimal that didn't end? Didn't we have something like that? Those are irrational roots. They're still real roots, but they're irrational. So the test that we're going to look at right here is specifically for rational zeros. And if it's a rational zero, then it's going to be a fraction or an integer. It is not going to be underneath the square root. Okay? So that's huge for you to realize that. So we're going to do some tests where we can find possible rational roots. We're not going to find all of the roots, but we're going to find at least the rational ones, and then if we can get it down to a quadratic, you can find the irrational ones after that, or the imaginary ones when we get to those. So the first thing that you want to look at is this thing called P over Q. And I wrote down here that P are the factors of the coefficient of the last term, and it's really the constant. Isn't your last term the constant? And if you don't have a constant, isn't it zero? Well, if you don't, you're always going to have a constant in these problems. If you don't have a constant, then we would end up factoring out an x, and you'd end up with a constant. So you're going to have a constant here no matter what. And then Q is the factors of the coefficient of your first term. So that would be your highest degree term if they're not in proper order. So if we look at this one, number 8, we're going to have to find all the zeros and the linear factors for 2x cubed plus 3x squared minus x plus 3. I don't give you any factors this time. So you could use long division, but where are you going to start? Do you have any idea? You're not allowed to look at your calculator either. Wouldn't you like a place to start? So this gives us a place to start. So we're going to start off by just looking at what are the possible factors. What I'm going to come up with doesn't mean that they are the factors, they're just possibilities. So we want to look at all the factors of 3, because that's our last term. It's always last over first. So all the factors of 3 divided by the factors of 2. So how many factors of 3 are there? How many? 2. Which ones are they? But could we have a positive 1 or a negative 1? And a positive 3 or a negative 3? Is that fuzzy, or is it just my imagination? A little fuzzy. Huh. That's not getting any better, is it? Oh, there, finally. That's too close in. Well, you'll have to deal with it. We'll go with that. All right, factors of 2, same thing. Plus or minus 1 and plus or minus 2. Right? We can't just leave it that way. We actually have to figure out what all of them are. So I'm going to take every one of these factors and put them over every one of these factors. So let's start with 1. If I put 1 over 1, don't I get 1? So one of my possible factors would be positive or negative 1. All I did was take 1 over 1. It reduces to 1. Then I'm going to take 1 over 2. Isn't that 1/2? You see what I'm doing? It's 1/2. So I have plus or minus 1/2. So I've exhausted 1, now I'm going to do 3. 3 over 1 is 3. So I've got plus or minus 3, and 3 over 2 is the fraction 3/2. So plus or minus 3/2. So these right here are my only possible rational roots. That's not to say that they're all the roots, they're just the possible rational roots. All right, so we have to find them. So this, at least we don't have a stab in the dark. We have some place to shoot for. Which ones do you not want to try in synthetic division? Because we discovered yesterday that synthetic division was much easier, right? So which ones do you not want to try? The fractions. You're not going to have decimals, but the fraction, I'm never going to start with a fraction first, only unless I'm forced to. So it's kind of like, start someplace, and then you're going to do synthetic division over and over again until you find a remainder of 0. Because once you find a remainder of 0, then you have a root, correct? All right, so step 1. Am I missing any x terms here? 3, 2, 1, 0. Am I missing any? No. So I'm going to start with synthetic division, 2, 3, negative 8, and 3. I have to decide what I'm going to put on the shelf. Out of positive and negative 1 and positive and negative 3, because those are our only integers, what would you like to start with? Positive 1 would be my most favorite one to start with, because it's the easiest one to do, right? So I'm going to start with positive 1 and go about your synthetic division. Bring down the 2 and then multiply. And then add down. And lo and behold, what happened? Aren't we lucky? We're so completely lucky that we hit it on the first try. So circle that 1, that's one of your zeros. Now the nice thing is, the minute I go from a cubic here, don't I end up with a quadratic here? Isn't that x squared and this is x? The minute you get it a quadratic, then you can factor. You can stop doing synthetic division and you can factor. So that's what I'm going to do next is I'm going to go back to my factoring roots. I'm going to take 2x squared plus 5x minus 3 and set it equal to 0 so we can factor it. I'm going to take my bookends, my 2 and my negative 3. I'm going to multiply them together. That gives me a product of 6. Because my product is negative, I know I'm subtracting the values of 6. It's really important when you're factoring 6 that you know whether you're adding or subtracting. Because there's only 2 factors of 6, 1 and 6, and 2 and 3. 1 and 6 subtract to give you 5, and 2 and 3 add to give you 5. Wouldn't it be important to know which one we're doing? Whether we're adding or subtracting, so it makes a huge difference, so you have to pay attention to that. I am looking for a positive 5. So what factors of 6 subtracts to give me 5? Subtract would be 1 and 6, right? My 5 is positive, so the bigger of the 2 always carries that same sign. So what does the 1 have to be? Negative. Now remember that these actually have variables attached to them. Our middle term is an x, so this is a negative x and a positive 6x. So then we're going to do the box thing. So take your bookends, the 2x squared and the negative 3, and put them on the first diagonal. Then on your other diagonal, you're going to put your 2 middle terms that you just came up with, a negative x and a positive 6x. Remember that these ones in red are the ones that carry the sign. Whatever the sign of these are, that's the sign that's going to be in your binomial. Because this one's positive, I know that this binomial, the middle sign is positive. Because this is negative, I know that the middle sign in this binomial is negative. So you can go ahead and put those out there immediately so you don't have to worry about signs. Then your GCFs you're going to find going up and to the left. So going up, for the first column, between 2x squared and x, what's the GCF? Just an x. And for the second column, a 3, right? Between 6 and 3, we have a 3. So isn't one of my binomials Here's the two binomials I'm looking for. One of my binomials is x plus 3. Then for my second binomial, I'm going to go to the left. What's my GCF between 2x squared and 6x? 2x. And between x and 3? It's a 1, and it is negative because of this box's sign is negative. And so our second binomial is 2x minus 1. So then you're going to set each of those equal to 0 to solve. So x plus 3 equals 0, and 2x minus 1 equals 0. So x is equal to what? Negative 3, and x is equal to what here? Positive 1/2. So these are our zeros, but they also asked for linear factors. So these are our zeros. Then our linear factors, part 3, we already found. But don't forget, oh, we forgot one of our zeros, didn't we? Isn't 1 a 0? So isn't another 0 also x equals 1? Let's include that in there. It's easy to forget when you do your synthetic division that, oops, there's a 0 up there. So our linear factors for this one would be what? If you set that equal to x equals 1, how do you make it into something equals 0? Subtract the 1. So don't you get x minus 1 equals 0? Oh, I really don't want the 0. So one of our linear factors is x minus 1. And then this one, before we solved for it, it was x plus 3. And then this one was 2x minus 1. So essentially we've just factored the whole thing. So these are our linear factors. Sometimes they're not going to ask for the linear factors. Sometimes they'll just ask for the zeros. 3 zeros, you'll have 3 linear factors. At most, how many zeros were we going to have? 3, and we ended up with 3, so they were all rational. And if I plug this into my calculator, two x cubed plus 3x squared minus 8x plus 3. Let's see how we did. Does that mimic the x cubed curve? Yes. Isn't this our negative 3? Isn't this our positive 1/2? And isn't that positive 1? So it agrees, right? Yeah. Those are the possible zeros. That's different than the real zeros. So she wanted to know, it's asking for the zeros. What we found up here are all the possible rational roots, or the rational zeros. That doesn't mean that they are. It's what they could be. Okay? The fact is, any polynomial that starts and ends with those numbers are going to have these as factors, or these as zeros. What makes a difference is what's in the middle. And so what's in the middle changes which one of these it is or isn't. And so that's kind of what happened here. These are the actual zeros, but aren't they part of that group? These are the actual zeros of that polynomial. So we have a group to choose from so that we don't just have a shot in the dark. It kind of tells us, pushes us to where we're going to find them. Okay? All right. So flip it to the back. Yes? Why does what? 1 is negative because the sign of that middle term is negative. The sign of your middle terms determine the sign of the second number in the binomial, always. So don't think GCF in terms of sign. Think GCF in terms of absolute value, and then look at what you put on this diagonal. That determines the sign that goes with that number. Okay? All right, so then example 9. Now we're going to find all the zeros and linear factors for this one. This is a fun one. Yikes. All right, so let's start off with listing all of our possible factors. So I've got a x to the 4th. So to find my zeros, I'm going to find all the factors of, oh, here's the problem. I have this 25 over 4. We can't have a fraction in there. So we either have to factor out a 1/4, which wouldn't be good for this, but instead, think of it this way. If I'm finding zeros, can't I set this equal to 0? And then if I want to get rid of the fraction because I don't want the fraction in there, it's going to affect our answer if we leave it in there. How do I get rid of the fraction? Multiply both sides by 4, whatever the LCD is. I have to multiply every term by 4 then, right? So 0 times 4 is still 0, so it doesn't affect the left. But my right side becomes 4x to the 4th. The 4's here cancel, so I get minus 25x squared. 4 times 9 is positive 36. So this is really the P and the Q that I'm working with. So now I have to look at those. So I'm really, unfortunately, looking at the factors of 36, and I'm dividing it by the factors of 4. The reason why I said unfortunately is, aren't there a lot of factors to 36? Mm-hmm. So let's start with plus or minus 1. Does 2 go in there?
Yes.
Plus or minus 2, how about 3?
Yes.
Plus or minus 3, how about 4? Plus or minus 4, 5 doesn't, how about 6? Plus or minus 6, isn't that the midway point? Then what goes with 4? 4 times what is 36? 9, so plus or minus 9. What about 3? 3 times what is 36? 12, plus or minus 12. 2 times what? 18, and then 1 and 36, so plus or minus 36. That's a lot more than last one, right? All divided by, there's a few more factors of 4, plus or minus 1, plus or minus 2, and plus or minus 4. Thankfully, we don't have a whole slew here. Now, there are some problems on your homework where you have oodles of possibilities. So we haven't even come up with the possibilities yet. Write small. Here we go. We're going to take every one of these factors of 36 and put them over each of these factors of 4. So obviously, if I put all of these over 1, I'm going to have all of these. So we're going to start with all of those. Plus or minus 1, plus or minus 2, plus or minus 3, and 4, and 6, 9, 12, 18, and 36. Okay? So that's all over 1. Then we're going to put them all over 2. Some of them are going to repeat. 1 over 2. Isn't that 1/2? So we have to add that one, so plus or minus 1/2. What about 2 over 2? That's 1, we already have that. What about 3 over 2? Got to add that. What about 4 over 2? We have 2. 6 over 2? We have 3. 9 over 2. That we don't have. So plus or minus 9/2. What about 12 over 2? So that's 6. 18 over 2. We have 9. 36 over 2. We have 18. So we're done with that one, right? So it didn't add too many. Now we're going to put them over 4. 1 over 4. We don't have that one, so plus or minus 1/4. 2 over 4 is 1/2. We already have that. 3 over 4. Don't have that one. So plus or minus 3 over 4. I'm out of room. 4 over 4. We have that. That's 1. 6 over 4. That's 3/2. We have that. How about 9 over 4? Ooh, we don't have that one. So plus or minus 9/4. 12 over 4 is 3. We have that. 18 over 4. 9 over 2. We have that. 36 over 4. That's 9. We have that. So we now have all the possibilities. And you're thinking, good heavens, can I have my calculator, please? Right? Nope, you can't have your calculator. But we're not going to try the fractions, are we? I'm certainly not starting there. What do you want to start with? I'd be starting with 1. So write yourself a note. These are all possible, rational, not the irrational ones, all possible rational roots or zeros. So, a little shy of a shot in the dark, we at least know where we're going a little bit. So, are we missing any, and we're looking at this one right here, not the original one, are we missing any x terms? Yeah, we're missing our cubed and our to the first, right? So we've got 4, negative 25. Our x cubed has a coefficient of 0, and our, I'm sorry, I just did that backwards. Our x cubed should be here at 0, shouldn't it? And then our negative 25 goes here. Didn't think I caught it. So that's my to the fourth, my cubed, my squared, then my x to the first is also a 0, right? And then 36. Draw your L, vertical line in your shelf. This is 25, not forget. All right, so what do you want to try first? 1? Right? I would always try 1. So bring down the 4, start multiplying. And what happened? Oh, didn't get a 0. Rats. All right, so we might want to try a negative 1. It's a possibility. Negative 1 is really easy to do right here, where we already did it, because it's just really a bunch of changing of signs. So if I change this to a negative 1, I still bring down the 4, but negative 1 times 4 makes this a negative 4, which added to 0 is still a negative 4. Negative 1 times negative 4 is a positive 4, so that one didn't change. Added to a negative 25 is still a negative 21. But a negative 21 times a negative 1 changes this to a positive, bless you, 21. Add down, this now changes to a positive 21. Multiply negative 1 times positive 21, that still is a negative 21, and we still get a 15. So both 1 and negative 1 gave us a remainder of 15. Aren't those symmetrical points? Interesting. That could be useful in the future. All right, so what do you want to try next? 2? All right, let's go with 2. So then step 2, we have to use not this down here because this never gave us a 0. We have to start all over again with this. So we're going to use 4, 0, negative 25, 0, and 36. So we're going to put in a 2. And what happened? Good choice, that 2, right? Whew, we found one of the zeros. Now the reason why I said that this paying attention to what happened with the 1 and the negative 1 would help you in the future. If 2 gave us an answer of 0, what do you think negative 2 is going to do? So how are you going to give me an answer of 0? And here's the problem. I'm not down to a quadratic. I started with x to the 4th. This now gets me down to x cubed. I have to find one more 0 before I can factor the old-fashioned way. So we've got to do one more synthetic division. Let's try negative 2, only because we saw that pattern before. You could start with this, and in fact you definitely need to start with this. 4, because we're using it to factor. 8, negative 9, and negative 18. So you do want to start with what you ended with. So this time let's put in a negative 2 and see what happens. Sure enough, what occurred? Did we get a 0? Yep. And so now we're actually down to our x squared. 0 would be our x term, which we don't need because it's a 0, and then this is our constant, which is great because don't you know how to easily factor 4x squared minus 9 equals 0? Right? We found two of our zeros. One is 2 and one is negative 2, and now we have to factor this. What factor pattern is that? Difference of two squares. So this factors into two binomials with a plus and a minus pattern. Square root of each of these goes in your binomial. So square root of 4x squared is 2x, and square root of 9 is 3. So when I set each of these equal to 0, what does x equal? Solve this for, yep, positive and negative 3/2. Was that one of our choices up here? Yep, and so was 2 and negative 2. So obviously we're throwing all the rest out. How many possible roots should we have come up with? 4. How many did we get? 4. So our zeros would be, so step 5, our zeros would end up being positive and negative 2, and positive and negative 3/2. So there's that answer. Then, didn't they ask us for the linear factors? So we already have these two, 2x plus 3, 2x minus 3. And then what about these two? What are they going to be? X minus 2 and x plus 2, right? So there's our linear factors. And so again, if you put this in your calculator to check it, it should cross where we're at. And I'm going to go ahead and put the original in so I can prove to you that this is this. So I've got x to the 4th minus, in parentheses, 25 divided by 4, x squared plus 9. It's a little w. So here it's crossing at negative 2. And then what's our other one? 1.5. So here's negative 2, here's negative 1.5, here's positive 1.5, and here's positive 2. Didn't it cross there? Okay? All right, we're going to do one more. So this is a bit much, isn't it? What if you hadn't chosen well to begin with? Could you get frustrated and easily give up? Sure. So then we have something else that could be a helpful clue to you, and they're called upper and lower bound rules. So upper and lower bound rules kind of tell you, based upon all of those possibilities that you come up with, you're going to lay fences. You're going to be able to find one of those possible zeros and say, okay, this is the upper bound. There can be no zeros that are greater than this one. And then you're going to find a lower bound that there's no zeros less than that one. So it even takes our possibilities and narrows it even further. And how does it do that? So it says here that if c is greater than 0, and c is not your constant, it's not what you're thinking. C is whatever you put into synthetic division, the thing that you're trying to find a 0 for. So c is a possible rational 0. Notice I didn't say it is a 0, because you can find an upper bound and a lower bound. And remember, not all of these up here were actual zeros, but one of them could be an upper bound and one of them could be a lower bound. And it might not be a 0, but at least it lays a fence in there so you can narrow down the field. So if you're putting in a positive number into synthetic division, if you look at the last row and it's either positive or 0, then C is considered an upper bound. For instance, I'm looking for an example. I don't see one we did here. Let's see, over here. Nope. Nope, we haven't come up with one yet. Well, we will here in a minute. We'll do one. Give me a moment. I'll prove it to you. So we're really looking at this last row here. Are all of these positive or 0? No. So I know that although 2 is a 0, it's not my upper bound. But you're thinking, but it's the biggest 0. That doesn't mean it's the upper bound one. So maybe if I chose 3 and put it in, we would get all positives in the 0. That doesn't mean that our remainder here has to be 0 for 3 to be the upper bound. In other words, 3 doesn't have to be a 0, 0 to be an upper bound. Okay? Then for our lower bound, Our lower bound is always a negative possible 0. If the numbers in the last row are alternately positive and negative, then you create this lower bound. See here on this one where we had a positive and a negative, the 0 doesn't count. You can take that one out. But see how I have a positive and a negative? It alternates. -2 is my lower bound. Let's see what that looks like. So let's do one last problem. Example 10, we're using synthetic division to verify the upper and lower bounds, and an R is missing, of the zeros of the function. So I have x to the 4th minus 4x cubed plus 15. What is my p? 15, and my q would be 1, wouldn't it? So I'm going to find all the factors of 15 and divide it by all the factors of 1. So what are my factors of 15? 1, 3, 5, and 15. And my factors of 1 are plus and minus 1. So that's easy. Isn't my numerator all my possible factors? Because if I put them all over 1, they are themselves. So these are all my possible rational zeros. Emphasis on rational, because you're going to be interested to see the answer to this one. All right, so I don't have too far of a field to go. So I want to use synthetic division. Where would you like to start?
3.
Where do we like to start? 1.
But I've got a good field.
So let's start at 1. So am I missing any x terms here? The squared in the first, right? So we've got 1, -4, my my squared is 0, my to the first is 0, and my constant is 15. So on my shelf, we're going to try 1. So drop down to 1 and start multiplying. And what happened? Didn't get 0. Do you see all positives here? Or 0? That means 1 is not my upper bound. Okay. So I got to go higher to get my upper bound. So what would you like to try? I'd try 5. We're going to skip a little step here. Yeah, you could try 3. You're going to find it's not your upper bound. So let's try 5. So we're still going to use the same numbers here. 1, -4, 0, 0, and 15. So we're going to try positive 5 because I'm looking for an upper bound, so I have to use a positive number. Misai, are you paying attention? Okay. So then I'm going to drop down my 1. So I have 5 times 1 is 5, and add down. So what happened? I don't have a 0 still, right? So what happened? Are they all positive? Okay. So I wanted you, I skipped 3 on purpose. I wanted you to notice that these are all positive. Or 0, I don't have zeros, but they're all positive. That means that this is my upper bound. 5 is my upper bound. So then, are they asking us to find the zeros? No. Just my upper bound. So did I find an upper bound? I absolutely did. All right, so I found it. So we're going to stop there. And in fact, you can put here upper bound also. So there we go. There's 1. And so then this is step 2. So step 3, we have to find a lower bound. So we're going to choose a negative value. What would you like to start with? Negative who? Oh, let's start with negative 1. Who wants to plug in negative 5? I'm going to start with negative 1. You can do what you want. So 1, negative 4, 0, 0. I do have a premonition about this, by the way. I'm going to plug in negative 1, a negative value, and multiply. Oh, look what happened. I had a sign change. Oh, another sign change. Oh, another sign change. And yet another sign change. Still didn't find a 0, but that's not the purpose of this question, is it? Notice what the numbers are. Positive, negative, positive, negative, positive. Don't we have alternating signs? Right? That means we found our lower bound. That means there's nothing lower than this. So if you had tried the negative 5, is that what you said? You wouldn't have found a lower bound. So let me show you a graph of this, and then we will call it a day. So let's plug this in. X to the 4th minus 4x cubed plus 15. Well, first of all, how many possible roots could I have? 4. How many are actually there? 2. It looks like 2 is one of them. And is that one of our possibilities? And if you actually find the 0 to that, it's very close to 2, but it's actually not 2. So 2 is not one of our possibilities up there, but it is an irrational root, this one. And this one is also, I believe, an irrational root, but that's neither here nor there. Our lower bound turned out to be what? Negative 1. Are there any roots to the left of negative 1? Nope. And our upper bound was 5, which is right here. Are there any roots greater than 5? What that did was it narrowed our range, so we only had to look at roots up there between negative 1 and 5. So if I were to then go do synthetic division, I would know not to choose positive or negative 15, negative 5, right? I would choose 1, 3, and that would only tell me if I had rational roots. If none of those worked, then I'd have some issues, right? Hopefully one of them works. But I have a feeling in this case, none of them are going to work. But neither here nor there, we did find our upper and lower bounds. Any questions on that? Okay.